Now I am discussing with you how to find the differentiation of function more than one time, which is known as higher order derivative, and especially at the level of CBSE and class 12th, we will discuss the second order derivative. I am going to make you clear it with the help of an example. Find d2y upon dx square if y equals to x cos x. Differentiation of y, it is dy by dx is equals to x first into derivative of second is minus sin x, plus second is cos x and derivative of first x, that is 1. It is first derivative which can be written as dy by dx is equals to minus of x sin x plus cos x. Now for the second derivative, d2y upon dx square is equals to minus is here, again x into sin x, we will apply here the product rule. First x into derivative of sin x is what? Cos x. First into derivative of second plus second sin x into derivative of first is 1. First into derivative of second plus second into derivative of first, then plus cos x, its derivative is minus sin x. So ultimately what is this? The final answer is d2y upon dx square is equals to minus of x cos x minus sin x is minus 2 sin x. This is the answer of the problem, that is the second order derivative. So simply higher order derivative or second order derivative means differentiate the problem successively 2 times. Second order derivative, if it is differentiated again, that will be the third order derivative. So this is only the approach to calculate, to obtain the second order derivative. Here you can say minus x cos x can also be again replaced by y if required, otherwise it's sufficient answer of the second order derivative. How to prove the results where the second order derivative is required to involve? If y is equals to a sin x plus b cos x, prove that d2y upon dx square plus y is equals to 0. We have y here. On differentiating this both sides with respect to x, we will say dy by dx is equals to a sin x means a cos x plus b cos x means minus b sin x. To obtain the second order derivative, again differentiating both sides with respect to x, so this become d2y upon dx square is equals to what? A as it is, derivative of cos x is minus sin x, that is minus a sin x, minus b sin x means b cos x. Doing the differentiation of the sin x is cos x. So we can say d2y upon dx square is equals to minus common, that is a sin x plus b cos x. But the value of a sin x plus b cos x is what again? Y. So answer of d2y upon dx square become minus of y. If this is shifted from right to left, net result is proved that d2y upon dx square plus y is equals to 0. This is the result which we want to show as per requirement of question. One more proof, that is based on the second order derivative. If y is equals to sin inverse of x, then prove that 1 minus x square, this is 1 minus x square times of y2. y2 means second derivative, that is what? d2y upon dx square, minus xy1 means x times of first derivative is equals to 0. We have y is equals to sin inverse of x. On differentiating, we will say dy by dx or y1 is equals to 1 upon root of 1 minus x square. On cross multiplying, this will be root of 1 minus x square times of y1 is equals to 1. Again differentiating both sides with respect to x, here it will be a product rule, first and second. So this is first 1 minus x square root as it is, first into derivative of second y1's derivative next time is y2 plus second y1 into derivative of first. Derivative of root of 1 minus x square will be, first it will be 1 upon 2 because power is half, 1 minus x square, that's to the power minus half, into what, minus 2x is equals to 0. So by doing so we are getting root of 1 minus x square y2, then we can say 2 and 2 get cancelled. This left y1 times of x, negative x y1 divided by root of 1 minus x square is equals to 0. This is the required result which we would like to show as desired in the problem. So these are the problems where we have obtained the second order derivative and we have proved some results for solving it. Now I want to discuss with you a problem where second order derivative in the parametric form is required. Find d2y upon dx square if x is sin t and y is cos t. To find it, first we will differentiate x with respect to t. We will get dx upon dt is cos of t, and the derivative of y, that is dy upon dt is equals to minus sin of t. If we divide dy by dt when divided by dx by dt, we will come to know the answer will be minus sin t upon cos t. So dt and dt get cancelled. dy by dx is equals to minus of sin upon cos, trigonometric transformation, tan t. To obtain the second derivative, what we will do, d2y upon dx square differentiating both sides with respect to x, it will be minus of sec square of t, minus as it is sec t sec square t, into dt upon dx, because t is the different form variable, so it will be dt upon dx. Hence, the answer of d2y upon dx square become minus of sec square t into dt upon dx. The value of dx upon dt is cos t, that's why value of dt upon dx will be sec of t. This become sec of t. So answer become minus sec of cube t. This is the second order derivative of the problem in the parametric form.